In this lesson, we're going to examine factoring, put it all together, all the different types of factoring. Our challenge is going to be to recognize which type of factoring we need to do it, and then remembering how to do it. So before we start, there's a flowchart you want to print off. We're going to develop this flowchart. In the top left corner of the flowchart, we're going to write down our first instruction, our first idea here, if you will. Okay. The first idea is, in order to go beyond common factoring, the largest exponent must be even. Okay? If that's not true, we can't go beyond common factoring. Okay? We always want to start with common factoring. Where we go beyond that depends on what we've got inside our brackets. So we're going to start with common factoring, top of a flowchart. If we common factor this one on the right here, we can take out a 4m squared, and we'll be left with 2m minus 1. We always want to check our brackets. Can we go further? So first of all, I'll check it. Do I have any exponents? If I do, and they're even, I might be able to go further. Now notice this has an exponent of a 1. That's an odd number. I can't go any further. That's it. That's all. I've done that question. Okay. Always check your brackets, kind of a key. Okay. Once we've done that, we've tried common factoring. It may or may not work. It depends on the situation. But if I've common factored, or if I can't common factor, the next thing I want to do is count how many terms I have. We have options: 2 terms, 3 terms, or 4 plus terms. So look at 2 terms first. There's 2 questions you want to ask yourself if you see 2 terms. Question number 1, is there a minus sign between them? If the answer to that is yes, well then, maybe we can go further. Can you square root both terms? If the answer to that is also yes, then it has to be a difference of squares. If either of those answers are no, then this is not factorable. Stop, you're done, you can't do anymore. Okay? But if they're both yes, we can do our difference of squares. In a difference of squares, we're going to take the square root of each term. So the square root of 9k squared is 3k. The square root of 100 is 10. And we're going to put opposite signs between them. And it's a difference of squares. Okay, so remember the big key here, opposite signs in each bracket. That's one of the common mistakes that I see is people put the same signs in. Need to be opposite signs. Okay, and then again, check your brackets. Can you go further? And I don't see any exponents, which means they're just ones, odd numbers, can't go further. Okay, back to our chart. What happens if we see 3 terms? We have some options here. Option number 1, let's look for a shortcut. Does the middle term equal 2 times the first term times the square root of the last term? If the answer to that is yes, well then you have yourself a perfect square. So for instance, the square root of 4m squared times the square root of 25 times 2 comes out to 2 times 2m times 5, which is 20m. That's the middle term. That's awesome. That means this is a perfect square, which means I can do this in one step. My square roots at the front and the back. I put a squared on it. And I take the sign of the middle term, and I'm done. A perfect square. And it saves you from having to do a simple trinomial or a complex trinomial. Even better. Okay, if the answer, however, was no, well then you have to look at the a value, the front number, the number in front of the squared term. If that value is just a 1, which if we look at this one, it is, right? Just the number 1 here. Well, if that's true, then we're using man. We're trying to find things that multiply to 100, add to 21, add to 21, and we have to figure the numbers that do that. The numbers in this case are 25 and negative 4. And it's with a simple trinomials, once you know your numbers, you have the answer. So c plus 24, c minus 4. Done. That's it. Okay, one step. That's why they're called simple ones. Unfortunately, they're not all simple. If the number at the front is not 1, that's your other option, well then you have a complex trinomial. The way we've approached the complex trinomials is we use the decomposition method, so man plus. So this times this. That gives us 12. I want to add to that 12 multiplied to negative 7. Numbers that do that are negative 3 and negative 4. And the order is not important that you put them in, but make sure when you replace the middle term, you put x's on them. And so we're taking 7 and we're turning it into these two things, right? Breaking it into pieces. We're going to common factor, so split it in half, common factor, 4x minus 3. Nothing comes out of the next part, except for the number 1, so we'll take the number 1 out. Sorry. Whatever sign is here has to come down, so negative 1, 4x minus 3. You know you're on the right track if your brackets match, which they do. So 4x minus 3 is my common bracket. My other stuff goes in the other bracket. And there's a complex trinomial. Okay, so there's the three types of trinomials: perfect squares, simple trinomials, complex trinomials. If it's not one of those, well, back to our chart, flow chart, it might be 4 or more terms. If it's 4 or more terms, we have to ask ourselves, can we group the items to create a common factor? Can we approach them like we did a complex trinomial? Split it in half and try and common factor each half. So if I look at this example here, okay, I notice in the first half I can take an x out. I'll be left with 2a minus 3b. In the next half I can take a y out, and again I'm left with 2a minus 3b. So by grouping them into two halves, I found a common factor that's the same in each half, 2a minus 3b. I'm left with x minus y. If you couldn't group them, then for now we can't factor. That's it, you're done, as far as you can go. Okay, check our brackets, no exponents, no factoring, we're done. Okay, let's try some examples. So flip the page over. On the back is a bunch of examples all mixed together. Now, I'm just going to go through them all. I would suggest you pause this. Try them yourself. Okay, so this first one's a simple trinomial. We want to multiply 24. We want to add to 11. Numbers that do that are 3 and 8. So x plus 3, x plus 8. Done. Second one's a difference of squares. There's two terms. There's a minus sign in the middle. That means I can square root them. X minus 5, x plus 5. Third one, common factor. They both have a 3a, so I take out that. Left with 2a minus 3b. I got no exponents after my brackets. I can't go any further. I stop. D. D is a complex trinomial. 6 times 10 is negative 60. I get things that multiply to that and add to negative 11. The numbers that do that are negative 15x and plus 4. So I replace the middle. I get a common factor now. So split it in half. 2x minus 5. Common factor of 4x and 10 is 2. Left with 2x minus 5. And my common bracket and my leftover stuff. Letter E, I notice that I can square root the first thing and square root the last thing. If I do square root the first thing, I get 2a, and the last thing I get 5. And 2a times 5 is 10. Doubled makes 20, which makes this a perfect square. So my sign is a plus, and I put my square on it. F, I notice they can all be common factored, so I'm going to do that first. And check my brackets, and I see an exponent for the first time, which means I might be able to go further. It looks like a simple trinomial, because my squared term is just a 1. I've got to find things that add to 1 multiplied to 72. The numbers that do that are negative 9 and positive 8. Okay, next set. Letter G. The first thing I notice about letter G is it's out of order, so we got to fix that before we start. We always want things in highest power to lowest power. Okay, it looks like a simple trinomial since the squared term is just a 1. I want to find things that multiply to 18, add to 11. Numbers that do that are negative 9 and negative 2. Okay, H. Looks like it has a common factor, so I do that first. I go to 5. I check my bracket, notice an exponent. I might be able to go further. And I have two terms. A minus sign in the middle, I can square root them, which means this is a difference of squares. So square root of 1, square root of the other, different signs in the brackets. Okay, I I look at my squared term, the one at the front, it's just a 1, which makes it a simple trinomial. So I got to find things that add to 4 and multiply to 12. Now the letters are often confusing here, so I'm going to deal with them first. X times x makes x squared at the front. Y times y makes y squared at the end. My numbers are -6 and +2. And that's it. Okay, you don't have to worry about the middle letter. It always takes care of itself if you take care of the first and last. Okay, time for some tricky ones. So, J. Now, J is weird looking. But if we looked at J as something like 9x squared minus 25, we would know what to do. Two terms, minus on the middle, square rootable. That makes this into a difference of squares. So let's approach it that way. If our question was 9x squared minus 25, we'd have 3x minus 5, 3x plus 5. We don't have x. We have this as our second part. So the square root of this term is 3 bracket y minus 1 minus 5 and 3 bracket y minus 1 plus 5. Okay, so I've taken the whole square root of 9y minus 1 squared and made it into this thing, the expression itself. That one's a little tricky. Okay, we've got another weird one, letter K here. K is weird because it's got 4 terms, but I can't split it in half and common factor each half. I look at it and there's nothing common to the first 2 terms except for A, and nothing common at all to the second terms. That's going to create what I want. So I got to try this in a slightly different way. If we look at this first 3 terms, that looks kind of nice. It looks like a simple trinomial. In fact, it actually looks like a perfect square, a plus 5 squared. So I have this expression now. Well, that reminds me of the one we just did in K. 2 terms with a minus sign in the middle, both of them being squared, a difference of squares. So the square root of a plus 5 squared is a plus 5. Square root of b squared is b. And because the difference of squares, I need 1 plus sign and 1 minus sign. And there's that one factored. It's a weird looking one. Okay, the last one. I notice I have y minus b here and here. If I could think of this as something like x minus x squared, I would know I could common factor. Well, let's do that. Let's take out y minus b, the whole expression. What would we be left with? 1 minus y minus b. Okay. We're thinking of this whole thing as one term. And there's your factored answer. Now you could simplify some of these if you wanted to. Y minus b, and we could inside the bracket get rid of the inside brackets, y minus 1 minus y plus b. It doesn't really change the question. It's not going to help us do anything at this point, but it would be simpler if you wanted to. Okay, last idea. Word problem. The area of a rectangle is given by this expression. Determine the expressions for the possible dimensions of the rectangle. So let's think about area for a second, if you will. Area is length times width. So if I could turn 20x squared plus 3x minus 2 into 2 separate things, I would know the length and the width. Well, doesn't this look like factoring? So let's factor this thing. This is a complex trinomial. So the complex trinomial, we got to do man plus. So 20 times -2, I got to multiply -40. I have to add to 3. Numbers that do that, 8 and -5. So we're going to replace. We'll have 20x squared plus 8x minus 5x minus 2. Just move this stuff out of the way here, okay? Yeah, we'll common factor each half. So common factor of the first part is 4x, and we're left with 5x plus 2. Common factor of the second half, I can only take out a 1. 5x plus 2 is good. My common bracket is 5x plus 2. Leftover stuff is 4x minus 1. Here's my length. is my width. Those are expressions for the dimensions of the rectangle. Part B, figure out the dimensions and area of x is 2. Okay. Well, my length we said was 5x plus 2. But we just said x is 2. That's what we were told back up here in the question. So my length would be 12 centimeters. My width, I can do the same thing. Now, you might say, well, how do you know that 4x minus 1 is my width? Couldn't it be the length? And sure, it could. I don't know which direction these go in. I'm just saying these are my dimensions. One's 12, one's 7. What's my area? Well, my area is length times width. 12 times 7 is 84. And there we go. I figure out the dimensions of this rectangle and its area. Okay, that's factoring. It's all review stuff, but we kind of need to know the different parts and pieces and how to identify them. Okay, some questions you should try. Warning, these are a little tricky in here, and maybe even a couple of these ones. They're kind of like the last row of examples. Okay, but do give them a try. If you're stuck, come see me.